Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 8, VPNs and IPsec concepts. So we're going to be looking at VPN technologies, types of VPNs, and we're going to end it with IPsec. So VPN technologies, they are essentially building a private virtual network through another form of a network. And this normally will create an end-to-end private network. So let me grab my pen. And so even though this is the internet, this is a public cloud, we can actually mimic a link through a public internet to make it seem like there is no network in between. The data is going to be encrypted so that there shouldn't be any form of confidentiality issues. We can do this site to site, location to location. We could do this with a mobile connectivity, mobile connector. So we could have a mobile worker connecting from anywhere, connecting to the internet, and once they connect to the internet, they can launch their mobile connector and then tunnel in from that application to the corporate network, thus being able to gain access to the internal corporate network resources. How do VPNs benefit the network or benefit the organizations? Well, it saves costs. It allows it to be more secure, especially as you have mobile workers accessing those resources. If they have to connect via a VPN, you can guarantee those resources are typically behind some type of firewall in the organization. It makes it a little bit more scalable. And lastly, the VPN technology normally sits on top of a layer 3 network, so it's compatible with traditionally any type of layer 2 or layer 1 technology. So any type of WAN connectivity, it doesn't really matter as long as are you able to get to the internet. If yes, then you should be able to leverage that connectivity to use a VPN. Again, mobile users use a remote VPN, oftentimes called a SSL VPN. However, that's not the only type. There is an IPsec layer VPN as well. An IPsec normally is used between point to point. However, it's not the only one. So when I say point to point, site to site, what does that mean? That means the end device, the router, the layer 3 device has a piece of software in it that actually will be tunneling through the internet to the remote device. They both have static addresses, so static IPs, and they're made to handshake with one another. Once they connect with one another, they will exchange certain information, and then it will build a tunnel through the internet. The internal hosts will have no knowledge that they're going through a different network. This device will look as if it is part of the local area network, part of the LAN. We have the ability to do a remote access VPN, and that basically dynamically creates and establishes a secure connection between the end device and our gateway. Here, the end device will actually do the call out to the VPN. However, this end device may have a dynamic address. It can be connecting from anywhere on the internet. So the end device has to do the call out. The VPN gateway will have to receive the connection and then establish the connection. So there's a few different types of VPNs. There's the enterprise managed and there's the service provider managed. Enterprise is normally what we're going to be dealing with. That's going to be things like the IPsec or GRE or other forms of Cisco VPNs. Or we could have, again, our remote access VPNs. That's going to be a client-based IPsec, a connection, or a clientless SSL connection. Those are going to be our main mobile types of VPNs. and that's managed by the enterprise. However, you can have service provider managed VPNs, and that's going to be a layer 2 or layer 3 MPLS, or older technology like frame relay or ATM. However, realistically on the Cisco exam, we're looking predominantly at the enterprise level VPN technology, and we're not even really scratching the surface. We're just discussing core concepts, and that's it. When we get to our CCNP level, that's when we'll start talking about configuring them. So types of VPNs. Again, the VPN is WAN independent. Clientless or client-based. A clientless VPN connection, this will allow the connection and securing using a web browser. A client-based, you'll have to have the software installed on your device, and the software will call out through the gateway and then build the tunnel that way. Both of these can use an SSL connection or an IPsec connection. So some SSL connection features. If we're looking and comparing SSL versus IPsec, normally SSL is limited to web-based applications and basic file sharing. IPsec is all around better. Authentication, both are fairly strong. Encryption type, again, both are pretty elegant. Connectivity complexity. IPsec normally requires you to install a client. SSL, you can do right through a web browser. The nice thing is SSL has way more connective options, where IPsec is very limited in its connection options. We've already talked about site-to-site VPNs, and again, normally this is done with the hardware, like the router. The router will build the tunnel. We have a few different types of VPN technologies, things like the generic routing encapsulation, GRE. While this is not really a secure site-to-site VPN tunneling protocol, it is one of the tunneling protocols that is discussed. So you can have secure and non-secure VPN technology. A GRE tunnel basically will encapsulate various network layer protocols, and it will use multicast and broadcast traffic. GRE does not by default support encryption, and there it does not provide secure VPN tunneling. A GRE packet can encapsulate an IPsec packet and forward it securely. The GRE is not doing the encryption. The IPsec packet is doing the encryption. A standard IPsec VPN, a non-GRE, can only create secure tunnels for unicast traffic. Unicast being 1-to-1. Encapsulating GRE into an IPsec will allow multicast routing protocols to update to use the secure connection through a VPN. Overall, GRE is not used for secure communication. However, GRE in junction with IPsec will build a secure VPN. So, what are some of the different layers within our GRE? So there's a few terms we need to look at. Passenger protocols. And that is going to be the original packet that is being encapsulated by GRE at layer 3. So that's either IPv4 or IPv6 or any form of layer 3 packet. We have the carrier protocol. And here the GRE will be the carrier protocol, and that will encapsulate the original passenger packet. Lastly, we have a transport packet, and that will be the protocol that will actually be used to forward the GRE packets to the destination, and that will be either IPv4 or IPv6. Here is the overall concept. We have the internet. We will build a GRE tunnel through the internet. Through that GRE tunnel, we will allow an IPsec VPN to build through that tunnel. The information going through the IPsec VPN is what is secured. The GRE tunnel is not secure. The IPsec portion of it is what is secure. We also have what's called the Dynamic Multi-Point VPNs, or DMVPNs, and this is part of the Cisco software solution for building multiple VPNs in a more easy, more dynamic, and more scalable manner. It does use a hub-and-spoke technology. It also uses what's known as the multi-point GRE, or MGRE. The MGRE tunnel allows for a single GRE interface to dynamically support multiple IPsec tunnels. Again, the MGRE, it does still handle IPsec, but it will handle multiple IPsec tunnels. The spoke sites can also obtain information about each other, alternatively building direct tunnels between themselves, so we can have a spoke-to-spoke tunnel, not always a hub-and-spoke tunnel. Realistically, at that point, we're building a mesh-type network. The IPsec portion will build what's called a IPsec Virtual Tunnel Interface, or IPsec VTI. VTI for short. Basically, the traffic will be sent from the end node to our branch router. The branch router will send it via the VTI through the VTI interface. The VTI interface is the IPsec tunnel, and it will be used to encrypt the data and forward it as a new logical interface. Because between our source and destination routers, the IPsec tunnel will build an encrypted tunnel. And how do we gain access to that tunnel? We gain access by using the virtual tunnel interfaces on both sides. That allows us to pass traffic to and from. The IPsec VTI can be configured between sites or between a hub and spoke based topology. We already kind of started talking about our service provider VPNs using things like MPLS. Well, what's interesting here is we can have a layer 2 MPLS VPN, and that will be called a virtual private LAN service, or VPLS. And this will be used to emulate an Ethernet multi-access LAN segment over MPLS. There, we're using our switching technology, so no routing would be involved. Again, at this point, we're essentially extending the LAN between two locations, so they'll all be part of the same multicast access network. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.